In this demonstration, I will use ANSYS BladeModeler on the example of a centrifugal compressor using Vista CCD and Blade Editor, a component of BladeModeler. Vista CCD is one of the mean-line sizing tools accessible from ANSYS BladeModeler and is based on software from one of ANSYS partners, PCA Engineers. Vista CCD is specifically for centrifugal compressor design and is used here to provide an initial blade design. In Vista CCD, I will specify the target duty, initial environmental conditions, working fluid properties, and geometric restrictions for the compressor. From these, Vista CCD generates an initial design. The initial design of the meridional flow path and the blade shape are then transferred from Vista CCD to Blade Editor, which provides the turbomachinery-specific capabilities of BladeModeler. BladeModeler also includes access to ANSYS Design Modeler, a CAD geometry modeling tool for geometry creation, modification, and simulation. With Blade Editor, I can further modify the initial design, creating a full 3D CAD model of the blade geometry, as well as incorporating any geometry features or components of relevance to a simulation using the modeling capabilities of ANSYS Design Modeler. In Blade Editor, a number of two-dimensional sketches are used to develop the full three-dimensional blade geometry. I can start with the two-dimensional sketches defining the initial meridional flow path. In this case, these have been passed from Vista CCD, and I can modify them from the preliminary design interactively. I can also parameterize them for use in an automated geometry creation and design optimization process. The blade shape is fine-tuned from the preliminary design using a set of two-dimensional sketches. For this centrifugal compressor, I can define and change the distribution of the blade angles and the blade thickness along the camber line from the leading to the trailing edge by manipulating a set of control points. These distributions can be specified and varied at any number of spanwise locations, so that I can completely and flexibly define the full three-dimensional blade geometry. As well, the same flexibility is available for the splitter blades. The Export Points feature can be used to transfer the blade design to ANSYS TurboGrid for high-quality mesh creation, specifically for CFD analysis of bladed turbomachinery components. For a design like this with a splitter blade, two profiles must be exported, one from the main blade and one from the splitter. Designs imported from Vista CCD, like this one, have these profiles automatically exported. If I need to specify a flow region for use in general meshing tools, I can create a three-dimensional periodic fluid zone corresponding to the region of fluid flow around a set of blades using the Stage Fluid Zone option. I can also use the sector cut feature to generate a three-dimensional sector of the solid hub that is aligned to the staged fluid zone. This is accomplished by revolving a closed-loop sketch curve about the machine axis. To do this, I will first copy a portion of the existing hub contour sketch and then transfer it to a new sketch. In this new sketch, I will extend the hub contour using Blade Editor's sketching tools. Now this sketch can be used to produce the sector cut. Notice that the hub, generated by the sector cut, and the fluid zone are appropriately aligned. The throat area feature is used to find and display the minimum area throat surface for the selected blade row, which may be an important consideration in the blade design. With my complete blade geometry model, I can then continue to the next steps in my simulations process for mesh generation and analysis within ANSYS Workbench. To summarize, first I created the mean line impeller design from Vista CCD. This was then transferred to BladeModeler using ANSYS Workbench, where I modified the three-dimensional design and prepared the impeller geometry for mesh generation and further analysis. This concludes this overview demonstration on the use of Vista CCD and ANSYS BladeModeler for the design of a centrifugal compressor.